I love helping people learn scientific topics. So when I went to graduate school, my first project was actually to develop a online tool training and teaching pharmacokinetics to pharmacy students at the University of Michigan. And I was accepted at the Smithsonian as part of their uh, innovations in technology at that time in 1997. And I just love helping people understand these scientific topics. I'm married. I have two kids. Both are also married, and I live with my wife in Utah, and she runs a baking supply store called Baking Me Crazy. So I started Aplos Analytics because I wanted to simplify data analysis. So the word Aplos in Greek means simplify or to make simple. And after 25 years in working in pharmacokinetic analysis, pharmacometrics, clinical pharmacology, I found that the tools that I had were inefficient, they were slow, and they were cumbersome to use, and they couldn't be automated. And so I felt like there was a better way to do it. Let's use new technologies and let's develop a way to do pharmacokinetic analysis that can be easily automated, that can eliminate the need for complicated software setup, and that can be insanely fast. I thought it was possible. And I actually chatted with my co-founder, Eric Wilson, and mentioned the idea to him. He's an expert in cloud-based development systems and software, and he thought it was a great idea so we put together Aplos Analytics and started the company just a few years ago, and now we have our first product on the market. Probably 90% of pharmacokinetic analysis is non-compartmental analysis. Certainly there's compartmental modeling, POP-PK, but that's a minimum of the total analyses that are done. And the dominant player right now is Phoenix Win Non-Lin. It's been around since the early 90s. The most recent update was in 2006 when the Phoenix platform became available. And since that time, which is now almost 20 years, very little has changed in Phoenix Win Non-Lin. At the time, it was a great software. It was all in one. It was a single platform. It was desktop software. But here we are 20 years later, and almost all the applications we use are cloud-based. They're accessible from our phones, from our tablets, from our computers. They're secure, they're fast, and efficient. And the tools we have now are none of that. And so we wanted to develop a tool that was a different path, that actually created this opportunity. So what we created was something that was serverless. It doesn't require any local installations, and you can directly send information to it, and it can calculate parameters for you. So you really only need two things for data analysis and non-compartmental PK. You need a data set, and you need a set of instructions to tell it what kind of data that is. And then you get their results back. So that's what Aplos NCA does. And it's significantly different because it eliminates all the work involved in setting up your analysis and allows you to do the analysis, get the results, and move on. And it can be automated from virtually any software. So you want to run it from R, go ahead. You want to run it from SAS, no problem. You want to run it from Python, no problem. You want to integrate it with your LIMS system, no problem. Any method to call the API, any software can do it. You want to build your own application that uses ours as a backbone, you can do it. And that's what's very different about Aplos NCA and why we developed it. So we're taking analysis that might have taken hours in the past, and you can do it in less than a minute today. So I've been using PK analysis software since the late 1990s. The most common software I used was Win Non-Lin. It was version 5, and then I was around when Win Non-Lin 6, Phoenix Win Non-Lin 6 came out. And actually, I was running the software development group at Certara when we released versions 7 and 8 of Phoenix Win Non-Lin. So it has been the primary software that's been used. And my experience is that it takes anywhere from 2 to 4 hours to run a non-compartmental analysis using that tool. You have to upload your data into that platform. You manipulate the data within the platform. You have to select drop-down boxes, radio dials, all sorts of settings that you have to set on multiple screens. And you have to make sure that the data inputs and data outputs are correctly connected. and then you can run your analysis. And the reason it takes 2 to 4 hours is that you're going through maybe 20 or 30 different screens to select the information. And it's overwhelming for new users. Which thing do they use? How do they do it? They have to watch videos. They have to take training. They have to spend hours learning how to do non-compartmental analysis when it shouldn't be that difficult. And so that's part of the reason why Aplos NCA is a product now, is anybody can do it on 2 screens. You upload your data, you set your configuration, which is what's the route of administration, what's the dosing, and what columns are your data or your information in. Then you execute it. It does everything else. It calculates the parameters. It's going to generate individual plots for you. It's going to generate summary plots for you. It's going to calculate summaries of all the parameters that you have, and it's going to put all that in a technical report that's in a PDF that's ready to go. So 90% of the work of the NCA is done by Aplos NCA, and all you had to do was upload a data set and set a few configuration options. In most cases, you can do that in under a minute, and what's even better about it is to QC it. It's a text file that's human readable, no software needed. So you can look at the configuration that was submitted with each analysis, and a human can read it and confirm that all the settings were correct, or if they're incorrect, you can go back and take another minute and redo the analysis. So it takes analysis from 2 to 4 hours for analysis, another maybe hour or 2 for QC, down to maybe a minute to 2 minutes to execute the analysis, another minute to QC it, and then you're done. So your time required to do the work is significantly reduced. It's almost infinitely reduced, because you can even automate many of these things through programming languages to take a data set that's ready, run the analysis, check that the inputs were correct, and move on, and then you go on to the next analysis. So Aplos NCA was built with automation in mind. So it's a fully cloud-based system that we can expand capacity based on need. So we can actually run, at a minimum, 3,000 simultaneous NCA analyses at the same time for any user. And we can actually have multiple users running them. And so what that means is we had a potential customer that was talking to us and said, hey, I have 300,000 PK profiles for a machine learning project I'm working on, and I need to generate AUCs and Cmaxes. How long would it take you to do that? And we asked if they're in separate data sets or single data set. He said, oh, they're in separate data sets. So we went back and we calculated, and we said, we can do 1.5 million profiles in about 15 minutes. So we could have that done in less than 10 minutes. That's the power of a cloud-based system, is we can expand as needed, and then we can contract. But what's beautiful about it is, for a single user, you don't need that much capacity. That's no problem. We give you an account that serves the capacity that you need. If you're a large enterprise and you have multiple users around the world using it, we can expand to hit that capacity. And we don't have to be there to actively manage it. It's built into what we have, where we spawn out new application entities when the requests come in, and then they reduce when they're not needed. So one of the most exciting current updates that just came out was the validation tool, which is free to all users. And what this does is it validates that the calculations that Aplos NCA are making in your instance are accurate. The way it does this is it takes public data sets of concentration time data, and it ingests those. It calculates NCA parameters using your instance of Aplos NCA. Then it compares the output to the known output that is also published. And if the difference is greater than 0.01%, it flags it as a failure in the test. And it goes through and it calculates thousands of parameters for these subjects, and it compares every single one. And if any one is different than more than 0.01%, that's a test failure. So we run six different data sets simultaneously, and then we look for a pass in all 6. If all 6 pass, then the result is a pass. So how long does it take to do this? About a minute and a half. So in a minute and a half, you're going to get results from 6 analyses, and you're going to get a report that has a pass-fail for each one, And if all the tests pass, you'll get an overall pass. You can validate any version of the software anytime, as many times as you like, and there's no additional cost for it. So if you need to do system validation and there's an upgrade to a new version, you punch one button, a minute and a half later, you have the analysis report to give to your QA group that you have validated your software. You also have confirmation of every version has been validated right there in your system. So you don't need to worry about setting up test scripts or anything like that. And everything's publicly available. So if you want to test the calculations against any other software that you have, whether it be R or Win-non-Lin, you could do it. And so that's a great advantage to users. You don't have to pay extra for a validation package. You can just get that included with any subscription. So new features that are coming. We're about to release the ability to support sparse data sets. So all the toxicokinetic studies that you have where you have sparse data analysis and you need to calculate the mean profile and then calculate the PK parameters for that mean profile. We're going to have that available to you. We're going to have the ability to do data line exclusions. So specific records need to be excluded. We'll have that ability to do that. We're going to have the ability to calculate partial AUCs. So a partial AUC is when you define the start and end time for an AUC that needs to be calculated, usually in the absorption phase, and this will calculate the partial AUC. So you can define what you want to call it, the start time, the end time, and then the interpolation method that's going to be used, and then it'll go ahead and calculate those. So we're super excited about all those releases and more as users suggest desired outputs and things that they need, we'll add those into the application, and we're rolling updates out every 2 to 4 weeks, and those updates are instantly available to you as a user. You don't have to change any installations. There's nothing for you to do. They're just available. So there's always constant pressure on advancing the science as well as being efficient with those advancements. So data analytics is receiving a lot of interest from AI machine learning approaches to looking at data, and that's absolutely wonderful. One of the challenges we have is that generating NCA parameters is a laborious, time-consuming process. In most cases, a scientist with a master's or a PhD is sitting in front of a computer, clicking buttons, and manually calculating NCAs. It takes time and effort. And there's operational efficiencies that can be gained by automating the standard analyses and freeing up those spectacular scientists to do other activities. They might want to do modeling. They may need to write protocols. They may need to review data and review analyses. Their time is now freed up to do that value add work, and the automated work of calculations can be handled by a computer that doesn't have feelings, never goes to sleep, and is very cost effective. So we think we're offering operational advantages as well as freeing up that human capital to do amazing things for pharmaceutical development. And this is no different than moving from manually created one-of-a-kind cars to assembly line automobiles. And we believe that we are the assembly line of data analysis for pharmacokinetics. I think the most exciting thing is having an idea and sharing it and having others excited about that idea and then working together to make it a solution. So I really have to thank my partner and co-founder, Eric Wilson. He's been spectacular to work with, and we had this idea that we said, we think this can work. And I think it went from an idea that was an interesting project to something that's a reality, that even Eric and I are amazed at how fast and efficient this is. We can't believe that we're down to 1.1 seconds for per profile for pharmacokinetic analysis, and we haven't even optimized it yet. So we're in the process of parallelizing it where we could get down to 500 profiles in about 20 seconds. And we're just super excited about this, about providing tools to help others. And you know what, I really love helping people, help them understand, help them execute. And what this software can do is open up PK analysis to more individuals. It's going to help biostatisticians who need to do PK analysis on their clinical studies. It's going to help bioanalysts who generate the concentration time data and somebody needs a quick PK analysis for their early stage drug development program. They can do it. It's going to take pharmacokineticists who spend all their time in front of a screen doing data analysis and free them up to do other more value add topics like writing protocols, reviewing analyses, proposing development plans. And so I'm just super excited that we've gone from this idea to a product that's on the market in about 18 months. And we're really excited for our customers that are going to help us bring this to the future.